Alright, this video deals with multiplying together monomials. So remember, monomials are just single terms. We're going to multiply together. We'll get to, in later videos, we'll look at when we're going to multiply monomials and polynomials. And that obviously gets a little bit more complicated. We'll get there later. For now, we'll start just with the basics, multiplying monomials together. Okay, so in order to visualize this, our first method, we're going to use Algebra Tiles, and we're going to think back to when we were looking at areas of rectangles. And remember that the formula for the area of a rectangle is simply its length times its width. Now, we are going to use that knowledge to draw out rectangles using Algebra Tiles. We're going to use each of these different monomials as dimensions, as either the length or the width of the rectangle, and the area, therefore, is going to be the answer to our problem, right? And length times the width is equal to the area, so we set each of the individual monomials and multiply those together. That's going to give us the result. So that's what we're going to do. So what I like to do when I do this is a little bit of a grid, a T-grid like this, and then very simply you draw out on one of the dimensions, either the vertical or the horizontal, the length or the width. You'll draw out the different algebra tiles. So I will draw 5 X tiles along here. Okay, and I will draw 2 X tiles along here. See, the 5x went on the top and the 2x went along the side. Now, in order to fill in this, we're going to use shapes that fill in each one. So a big square is going to fill in when I multiply together one x by another x. It's going to give us a big square, an x squared, and same thing for each of these, and you'll see that by the end we have one large rectangle made up of all of these x squareds, and that's going to be the answer to our statement. So we count up how many x squared tiles there are. We see that there's 10. Our answer is 10x squared. So the result of 5x times 2x gives us 10x squared. Okay, we'll do another example. Again, we'll set up our grid, and we'll draw out our two different dimensions. We got 3x and 2x. Okay, and again, we fill in the grid. And you get fast at this as you go. Remember, those are positives because they're positive times positive. Okay, we have our complete rectangle. We look at it and we count up that it is made up of 6x squared tiles. Therefore, that is the answer to 3x times 2x is 6x squared. Okay, so again, that's a good way to visualize, kind of see what's going on. Algebra is kind of an abstract concept, so if you can see it with algebra tiles, that might help you. Probably at some point you'll get to the point where you'll say that that is a little tedious or a little extra work, and you'll see that there are ways to do it without drawing out all these algebra tiles, just using algebra. So really our trick is not too complicated. We simply multiply coefficients and then we multiply variables. And remember, when we multiply variables, we go back to those exponent laws that we looked at back in Chapter 2. So hopefully you're familiar with those. If not, you can go back and review some of those videos from them. Okay, so an example here, we're going to start by multiplying the coefficients. Remember, the coefficients are the number part of a term, the part that's multiplied by the variable. So we've got 11 as one coefficient and 2 as the other. Multiply those together. 11 times 2 is 22. Okay, then we take the variable part of it. We have a in one and a b in the other. Okay, so you remember back to our exponent rules. When you multiply variables together, if they're the same base, you end up adding the exponents on it. If they're different bases, well, you can't really combine them, so you just take both of them, so the variable part a times b is just going to be left as ab, so our overall answer is going to be 22ab. Okay, let's do another example. This example is again same idea. We're going to follow the same pattern. We're going to identify the coefficients, -5, well, and then this is just a numerical part. There is no variable with it. So we're going to multiply together the number part of it, and then we'll add the variable in it. -5 times 3.2 is 16. Okay, and remember it's a negative times a positive, so that makes it a -16. Okay, then we need to make sure that we include that variable part as well, so -16x. Okay, that's all there is to multiplying monomials. You get a little bit of practice doing that. You'll be a whiz at this in no time. Okay, hope that helps.